Hey, what's up, guys? This is Chung here again. So this time, LeetCode number 1498, number of subsequences that satisfy the given sum condition. Okay, so you're given like an array of integers, right, and the integer target. So your task is to return the number of the non-empty subsequences from these nums, right, such that the sum of the minimum and the maximum element in this subsequence is less or equal to the target. Right? So and then do a modular by this 10 to the power of 9 plus 7. Right. So now this one is about the subsequences, and it's about the number of subsequences. Right. So for example, right. So we have these numbers 3, 5, 7, 6, 7. Right. And the target is 9. So the answer is 4. So the reason being is that there are like 4 subsequences, right, whose minimum and the maximum number, the sum is smaller than 9. So we have 3, 3, 5, 3, 5, 6, and 3, 6, right? And notice that 5 is not. First 5, 6 is not. This one is not a valid answer because this one, the smallest is 5, the biggest is 6. This one is 11, right, which is greater than 9. And also 5 is not the answer either, because for the number itself, the minimum and the maximum, it's the number itself, right? So this one is also greater than 9. That's why the total subsequences for this one is it's 4. Oops, sorry. Let me change this one to okay. And another example, right? So this one, the answer is 6 because, as you guys can see, we have 6 subsequences. So notice that same numbers on a different index, we treat it as different subsequences, right? And here are some constraints, right? So 10 to the power of 5, something like that, right? Cool. So at the beginning, when I saw this kind of problem, because I see this kind of number of subsequences, I was trying to solve this one with a DP concept, but then I started thinking about for, as you guys know, right? So for each DP problem, we need to define like a DP state, right? And for this one, I'm trying to define like a DP state, something like if I can use like the current index plus the current minimum and the current maximum, right, as a state, can I calculate the valid subsequences, right, starting from the current index to the end, right? But I think that's because that's gonna be a weird state, because even though we define that state, it's hard for me to come up with like a very clear DP state transition function, because with the current index and the current minimum and the maximum, right? I mean, later on we might have like we may have like a smaller or bigger number than the current minimum and the maximum, right? So which means the current state cannot represent everything starting from the current index to the end, right? And then I was like, maybe we can sort these numbers, right? And then we know, okay, so it's all the later one. The later one is also it's always greater than the current one, right? That actually that's a good start, But if we sort it, right? I mean, then we don't even need to use a DP, right? Because we know the current one is the smallest index. Sorry, the smallest is always the minimum number for all the subsequences starting from the current number, right? And then all we need to know is that we just need to know the ending index for all the subsequences, right? Who is starting from the current one. So what does that mean? It means that, for example, if we have 3, 5, 6, and 7, right? So we have a left. Let's say we have a left and right pointers. We have left and right. So at the beginning, left is equal to 0, and the right equals to n minus 1. So this is left, and this is right, right? So basically, we can use this kind of 2 pointers. So first we sort this arrays, right? I mean, whenever the left one plus right one is greater than target, right? Then we know, okay, we need to move the right pointer to the left, right? So now the right pointer is here. Now 3 plus 7, because so the reason we do this is because since the left pointer it will always be pointing to the minimum value, and the right pointer will always be pointing to the maximum value for the current subsequence range, right? So let's say we have 3, 5, and 6, right? So now we know, okay, so 3, 6 it's within the range in target. So which means that this with this 3 number, with this kind of numbers, right? We can get some subsequences out of this, right? But what's going to be the strategy? So ideally, I think you guys all know that the total number of subsequences with 3 number is what is 2 to the power of 3 minus 1, right? I mean, this is the non-empty subsequences, right? So basically, we have like 7 total subsequences, 7 non-empty subsequences, right, from this one. But like I said, use we cannot use all of the subsequences. So our restriction here is that we have to include this 3 here, because otherwise, so the reason being is that so the precondition we can use this 3 number is that we have to have like a minimum number as 3, right? We have to fix this one because otherwise, you know, it, like I said, if we only have this 5, right, and then the minimum number will be 5, because we're saying that we need this minimum number to be 3, right? And if we have fixed the minimum number to be 3, then I don't care about the maximum number starting from this 6. It can be anywhere between the 3 and between the left to the right, but we have to include this 3. So which means that instead of 3 here, right? So we need 2, right? Because this one is fixed, so we only have like 2 numbers left. We can do like a full subsequences of these 2 numbers, right? And in this case, right, actually it's gonna be we don't need to do a minus 1 here, because we could have like empty subsequences here, because like I said, 3 is also like 3 itself without any of those 2 numbers can also be a subsequence by itself. Okay, right? So now I think it's pretty clear, right? I mean, we have our logic then, basically, Oh, and a little bit about this 2 to the power of 3, right? So let's say we have 3 here, and now we have a lot of numbers here. So this is like 9 something, right? So basically, this is the right, this is the L. This is still the same, right? So it's gonna be a 2 to the power of right minus left. this is gonna be the total number, total possible subsequences for this kind of in this range, right? Cool. And after this, right? Basically, after calculating the subsequences from left to right, then what's next? Then we need to move the left to the right, to the right by 1. So basically now left is pointing to here because, like I said, so this one is for all the subsequences, that's including these 3 here, right? So now we need to check, is there any other subsequences, available valid subsequences that basically starting from this number, right? So basically, and then we just go back to our original logic. After moving left, we also check if the left one plus the right one is within the range of target. If it is, then we use the same like formula here. Otherwise, we keep moving the right to the left, right? Because the reason we can use like 2-pointer is because, like I said, every time when we move the left pointer to right, so the left numbers will always become bigger, right? So if we have a right here, so the right pointer will always be moving to the left, because since the left one is always becoming bigger, and in order for the subsequences, for the minimum maximum is less than the target, every time we can only move the right pointer to the left. It doesn't make sense to move the right pointer to the right, Because whenever get a smaller value. That's why how this kind of 2-pointer logic works. Right. I mean, a little bit. So for this one, I know this one is pretty straightforward, right? I mean, basically, how can we get 2 to the power of this one? Because if we have 5 and 6, right? I mean, how many totals subsequences we have here? We have like 5, we have 6, and then we have 5, 6, right? And now, of course, we always have an empty one, right? That's why the formula to calculate all the subsequences, given like with n numbers, it's gonna be a 2 to the power of n, right? And since actually -1, but since we're also including the empty one, that's why it's just a 2 to the power of n. Okay, cool. So let's start coding then. So the coding should be pretty straightforward, right? So first I sort this number, and then I have this kind of length of nums, right? And then we have a left starting from 0, right n minus 1, and I have the answer equal to 0, right? So we have 2 pointers so while the left is equal to the right, So if the nums of left plus nums of right, it's within the range of target. Okay, then we know we can calculate all the valid subsequences, right? Within the range, for the range from left to right, where the left number, the pointer left's number is always included, right? It's going to be a 2 to the power of r minus left, okay? And then we increase the left by 1, right? Else we shrink the right pointer, and then because only by shrinking the right pointers, we could possibly get like a smaller sum for these 2 numbers. Okay, and then that's it, right? We have a mod going to be a 10 to the power of 9 plus 7, and then we simply just do a mod in the end. Okay, so that's it. Okay, accept it if I run it. Cool. So this one is like pretty It's kind of slow, but I guess this is as good as we can get from this one. You know, as you guys can see, the time complexity for this is like O of n log n, right? Okay, because we have sort, and then here is just like O of n, right? So what else? Yeah, I think that's pretty much it is, right? I mean, so again, right? I mean, the reason we want to approach from left and right is that, you know, let's say we have three again, right? We have three, this kind of thing, you know, after sorting, we have 9 here, right? So the first time this this condition is satisfied, right? Which is 3 and 9, right? This is the left and this is right. Since we have already sorted, you know, the first time this one is satisfied, and the left and the right is the maximum, basically is the boundaries, right? For all the subsequences, uh, who includes this 3 number. So which means that, you know, for all the subsequences who includes 3 here, you know, we can only go as far as 9 here. Okay, and because anything after 9 here is going to be what? It's going to be 10, right? Let's say the target is 12 in this case, right? So, and every time we have a if statement, we go into the if statement, and then we know, okay, so the current right is the boundaries of the range for the current subsets, the subsequences. That's how we can how we can sure, right? We can use this formula to include all the possible number of subsequences, right? Who includes this number 3 here. Similarly, right, once we process this one, and we move to here, and then if this one still, if this one is 3, another 3 here, right? And then we see, okay, 3 is this one, and then we know, okay, so it's again, right, every time this R is pointing to the boundary, right, to the furthest number this current subsequences can go. Yep, I think that's pretty much everything I want to talk about for this one. Yep. Okay, cool. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.